Hello once again, our most valued student. My name is Confident. Welcome to our continuation of the Mathematics N4, and I'm looking at the paper that was just written on the 29th of June 2022, and I've already looked at the first question, and which means if you have missed out on this question, it simply means that you are not subscribed to this channel. So what I will encourage you to do right now is to ensure you subscribe to the channel and also ensure you turn on the notification bell so that you are notified every time I post a new video. So as I said, this is Mathematics N4 and I'm looking at the previous paper that was just written, and I've just looked at the first 20 marks, which is question 1. Now I'm continuing to look at question number 2, and question number 2 purely focused, I think here it is on graphs. So now let's look at this question number 2, and then 2.1 is the first question. It says show that log in base 1 over a of y is equal to negative log in base a of y, and then it says and hence determine the value of x if that is that. Then they give you 5 marks for that. Now look at this. You are given here, let me just make this bigger and then we can take it back. So we are given this log to say we need to show this. That's what we're given. I need to show that. So if I can in a way write this down here, let me make it smaller now. If I can in a way write this down to say log 1 in that's the base 1 over a of y is equal to negative log in base a of y. So this is what I'm supposed, or I'm given here, just to give it space. Alright, this is what I'm given, and I need to show or to prove that the left hand side is equal to the right hand side. So let me consider the left hand side here. So let's consider our left hand side to say let log 1 over a, I mean base 1 over a of y, let it be equal to x. Right. So now how do you simplify this if it's x? So it means y is equal to, if you remember how you change from logs to exponents, so y is equal to 1 over a to the exponent x. That's how you're converting from what? Logs to exponents. Okay, so what it means here, if you convert 1 over a, remember 1 over a is simple a to the power negative 1. So you've got y is equal to a to the power negative 1 that multiplied by x, which is y is equal to a to the power negative x, because 1 times x is negative x. So if you have done that, we can now make x the subject of the formula. You introduce the logs again, so you are going to say log y is equal to log a to the power negative x. I'm just using the simple base of 10 there, and then which means log y is equal to negative x is negative x log a. So I want to make x the subject of the formula now. I think that. So when I've done that, it's log y is equal to negative x log a. So now if I can divide here by let me divide by a negative 1 over negative 1 first. So what I will have is negative log y is equal to x log a. I think that then I can then divide by log a over log a. Alright, so if I have done that, which means what I'm saying here is negative log y over log a is equal to x. Alright, but remember if I say to you log in base of, if I say log in base of 2, okay, let me use just let me use real numbers here. If I say log in base of 2 of 3, this is the same. If I want to convert this to base 10, this is the same as saying log base 10 of 3 over log base 10 of 2. Just test this so that you can just have an idea what I'm talking about. So if I can just use my calculator here just to test, to say log base 2 of 3 is equal to 1,584. You see that? But I say that 1,58, I can get it by saying log, I'm just using 10, but you know log 10 is 1. So 3 over log, okay, over log base 10 of what? Of 2. I must get 1,58. So you see that is the same thing. It also means the same here. If I bring this into this means negative log y, there is at base. See that? I can convert it to say here log base a of y is the same as saying log, because that is a base 10 there. There is a hidden 10 there, but let me leave it out. It means if I'm leaving out that, is same as log base y over log base a. So this is what I have. Therefore, if you check it now, we go back from the beginning. It means what we started with, which was what? Log base 1 over a of y. If I can write that back to say log base 1 over a of y, we said let that be equal to x, and you see this is our x, which is equal to negative log base a of y. See that? So that we have proved. The question was saying given that given that, show that this is equal to that. So we've shown that. And then the next question says and hence, so which means from what we've been doing, says hence meaning continue with what you were doing from the previous one. Says hence determine the value of x if you are given now this one, log base 3 of 3 minus x is equal to log that. So let me write this down and then I'll take it out. It's log base 3 of 3 minus x is equal to log 1 over 3 of 5 minus 2x. So hence determine the value of x. So if I can then take this further down, remember it says hence, so I just want to take it along to where I've been working out this thing so that it can now make sense. I'm just bringing it along here. Alright, so this is where I am now. So we are given this to say hence determine the value of x. So I've got this, but now remember I've got this part to say I know using this condition here. Let me just give you this condition. That's what we were using. We used this condition here. Let me actually duplicate this. So we have this condition which says if I'm given a fraction of a log, look at this one, the fraction will become that, which means if I want to take this further, it means log 1 over 3 of 5 minus 2x, see this one, it will be equal to, just like I had here, so my 1 over a is the 1 over 3, my y is that, see that, is equal to negative, now I'm focusing on this now, is equal to negative log, now my a and y, see what is happening there. So if my a, it was 1 over a, it becomes a, so here it will become 3, and then my y will become bracket 5 minus 2x. Do you see what's happening? Then I can conclude and say, therefore, this part, log, from here, I can conclude and say log base 3 of 3 minus x is equal to this part now, negative log base 3 of 5 minus 2x. See that? That is the hence. I've used that to do that now. But for me to be able to continue, I need to take this negative. There is a negative 1 here. I need to bring it back there as an exponent. Remember, if I say here, for example, log base a of b to the power x, this is same as saying you drop the x to say it's x log base a of b. So which means this x can even go back there as an exponent, so it will become x as an exponent. So same thing, I want to take the negative 1 back there, so it will be log base 3 of 3 minus x is equal to log base 3 of 5 minus 2x. Now this is to the power negative 1. You see that? Now why am I doing that? I wanted to come at this stage here to say, if I'm given log base a of b is equal to log base a of c, therefore when the bases are matching, it means b is equal to c. See that? Even here the bases are matching, it means that bracket, which is 3 minus x, is equal to that bracket, which is 5 minus 2x to the exponent negative 1. Then I have to solve for x here. And how do I solve for x here? That negative 1 is same as saying 3 minus x is equal to 1 over 5 minus 2x. See that? Then I say over 1, cross multiply here. Remember, now I'm solving for x, so it will be 3 minus x bracket 5 minus 2x is equal to 1 times 1, which is a 1. Then I need to open up this bracket, 3 times that, and that times that, that, and that. That's what I need to do. So 3 times 5, I get 15. 3 times negative 2 is negative 6x. Negative x times 5, negative 5x. Negative x times negative 2x is plus 2x squared is equal to 1. Then I need to solve for x quickly here. So what I have 2x squared minus 6 minus 5 is negative 11x. And then 15, the 1 will go this side, it will be 15 minus 1 is plus 14 is equal to 0. So in here I need to find the value of x. I can quickly use, without a problem here, the quadratic formula to say x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So I've got my x is equal to negative 11 plus or minus negative 11 squared minus 4a is 2, 4ac is 14, and all over 2a is 2. So it will quickly give me two values of x. Actually, let me write them here so that I don't go further down. So what do I have? I've got two values of x. X is equal to, I can just quickly rely on my calculator here to say negative 11, that is 2 negatives there. Alright, then it's plus square root of negative 11 squared minus 4. My a is 2, my c is 14 over 2 and 2 equal to 7 over 2 is the first one. 7 over 2, put a minus there, and 2. X is 7 over 2 and x is equal to 2. So these are the values of x that I'm having here. So I've managed to solve. Remember, the question was solve for x. So if I can just duplicate this to say, let me further, I want to further take these answers to my original question just to see if ever we can test whether it's correct. So let me take this and bring it into the original. Sorry about that. I'm just bringing it into the original. Let me make this smaller so that I can quickly take this. So where am I taking it? I'm taking it into the original. Remember, you have to always test your answers. It's always important. So now if I can take these two values here, because the question was what? We need to solve for x. So if I can bring this here to say solve for x, remember it says x is that and that. Now let me try it. The first one, if I'm testing my answers, so I need to bring the first value of x as 7 over 2 and see if the left hand side is balancing with the right hand side. So look at this. I've got log base 3 of 3 minus 7 over 2 right, and then that is equal to, see, I'm getting an error, so that is not equal to. So the first value is not doing it. What about the second one? If I've got 3 minus, where x is equal to 2, sorry about that, minus 2 is equal to, I'm getting a 0 on the left hand side. Let's do the right hand side. Log 1 over 3, and then I've got 5 minus 2 times 2, alright, equal to, I'm also getting a 0. So you can see that the one that is balancing is that, so this one is not. So the answer only is that. Then you can say therefore x is equal to 2, or you can just leave it and say x is not equal to 7 over 2 or x is equal to 2. So that is how you can simple solve that. It was quite a bit of working there for 5 marks, but I think it's worth it. Alright, let's look at the next question. The next question is question 2.2. It says in question 2.2, given p is equal to k, 1 minus 10 to the power negative x over y, make y the subject. So let's make that bigger again, just to get an idea what we're dealing with. We are having that. So if I can write it down to say p is equal to k, 1 minus 10 to the negative x over y. So if I can work this thing from here, and yeah, we are making y the subject. It's a common algebra. This is not really complicated. This is simple algebra. Now whenever you see y there being an exponent, chances are you will introduce either logarithms or you can work with ln. So let's do first things first. What we need to do is to divide by that k, because k is multiplying. So we divide by k, we divide by k, so that goes. So what we have is p over k is equal to 1 minus 10 to the power negative x over y. Are you getting that? But now I'm seeing that 1 can jump that part, but I just want to also solve that negative. So it's better for negative 10 to go here and p to come this side, so that it will become now positive 10 negative x over y is equal to 1 minus p over k. See what I was trying to drive at, so that I avoid working with a negative 10. So when I've done that, I can then introduce logs. I think here is better because there is a base 10. Remember, log 10 is equal to 1. So that's the part here that I want to bring to say, if I say to you, what is log 10? Log 10 is 1. Why? Because I'm in log 10 not log base 10, but it's already in base 10. If I say log 10, this is 1. Why? Because the base there is 10. So if I introduce logs, I will have log 10 to the power negative x over y is equal to log, then you put the bracket here, don't forget, very important to do that. Okay, then you can take that exponent and drop it to say negative x over y log 10 is equal to log, and then I've got 1 minus p over k. I think that, and then you can finalize this and say, remember log 10 is 1, so it's negative x over y bracket 1 is equal to log 1 minus p over k. And then from here, remember we're making y the subject of the formula. You can multiply by y, you multiply by y, so that goes, and you will have negative x in here is equal to let me leave it as is, 1 minus p over k, and then it's times y. My aim is to make y the subject, so I have to divide by what I don't want on the left and the right. So I don't want this log 1 minus p over k, so this will go and I'll remain with y. So on the other side also, if I divide log 1 minus p over k, alright, so now it will then give me y as the subject to say, therefore y is equal to negative x all over log 1 minus p over k. Then I have made y the subject of the formula, and that is the part here that this question was requiring. It was saying given p is called this, make y the subject of the formula, and it is giving you 4 marks. So let's look at the next question in that part. The next question is question 2.3.1, says sketch the graph of that y is equal to this. But now if I looked at the instructions of this paper, something was not common here. They said requirements, they required a graph paper now. So if you are using a graph paper then to answer these questions, I think I'm going to draw then this on a graph paper to say, if I'm to sketch this, and then let me bring in some kind of a graph paper here. Sorry about that. So if I'm to sketch this, what it will look say is y is equal to minus 3 minus 3x over k, but this is a straight line graph. So what you simply do is you come up with two values of x, two values to say when x is equal to 0, what is y. You can see that if you put a 0 here, this will become 0, so it will become y is equal to negative 1. You can choose also to make y equal to 0, but sometimes you can maybe choose even a bigger value here to say something that is a multiple of 3, just to make things easier. For example, if I just take my calculator here, remember guys, this is just plotting a straight line graph, so you just need something simplified. If I say when x is negative 2, let's say x is equal to 6, let's use 6, not 3, let's use 6, so that it can be a multiple of 3 at the bottom. So it's negative 2 6 over 3 minus 1 is equal to negative 5. So when x is equal to 6, y is equal to negative 5, not negative 1. So I got these two values. So what I can do now is to plot them. Let me just bring them closer. So I need to plot now these on my graph paper here, because the question was sketch. Okay, let me take everything along. So this is what I want to sketch here. So if I'm to sketch that point, let me have just my line like this, and I can have my line like that. So I've got here my y, I got here my x. Are you getting that? So I can make this point 1, 2, 3, 4, 5, 6. This is my -1, -2, -3, -4, -5, -6. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So this is -5, and this is 1, 2, 3, 4, 5. This is 6. I'm not doing much on it. This is 1, 2, 3, 4. This is a 5. This is 1, 2, 3, 4, 5. This is a 6. This is minus. I'm just doing this quick. You can just fill it up, of course, with everything. Now let's look at this. When x is 0, y is -1. When x is 0, y is -1. There is a point here. And then when x is 6, what does it say? Y is what? When x is 6, y is -5. We have a point there. So this is a graph with a negative gradient. It does make sense. So when I'm drawing this graph, let me choose a 1 where x is negative and y is positive. So let's choose 1 here so that we can have maybe a third point to say when x is positive. Maybe let me choose actually when x is negative. So it's -2. I can choose actually -6 on the side. -6 over 3 minus 1. Let's see if it will be within range. I got a 3. So when x is -6, y is equal to 3. I can add it here. X is -6, y is equal to 3. So I can have that point here. Say when x is -6, 1, 2, this is 3 there. Okay. So my point is somewhere here. So I can actually have now my line coming all the way. It's a straight line graph. You see that? So that is a straight line graph, and that graph is y is equal to minus, I think, is it 2x? Let me check that graph. It's -2x over 3. So it's -2x over 3 minus 1, I think. And that is that. Yes. So the question was, sketch this graph. Is 2 marks. It's a straight line graph which you mustn't struggle sketching. So this is the kind of graph that we have. It's a straight line graph with a negative gradient. Now look at the question now. Is the graph of this continuous or discontinuous? Now whenever you're talking about continuous or discontinuous graphs, how many marks is that? It's 1 mark. Now continuous means for every value of x, do we have a value of y? Yes. Whatever value of x can approach infinity. Even here, y will also approach infinity. So for every value of x, we will get a value of y, meaning for every domain there will be a range. So yes, this graph is what is continuous. Next one, is the graph of this a function or a relationship? Now what is a function and versus a relationship? Now a function means if I can say x, okay, let me just do this. If I'm talking about a function here, let's say I've got the x value, it means there is also a corresponding single y value. It must be 1. For example, if you look at this part, when you said x is 0 and y is -1, so I had x being 0, y being -1. You can see that for every single value of x, there is a single value of y. Also, we did another one. For example, x is 6, y is -5. 6, we got a -5. There is a single absolute value from the range to the domain. So this means it is a function. A relationship, sometimes you might find a situation like this whereby you'll have x here and y here. For example, you have got x is 2 and y being maybe -3 and +3. So now this is no longer a function whereby one value of x, I mean, not actually, let me use it the other way around, where it's common to say when x is, I'm using like this function. Let's say, for example, y, I'm just choose something different. Let's say y is equal to what can I say? Y is equal to x squared. Let's use that one. So now look at this. When x is equal to -2, now y is equal to 4. And when x is equal to 2, y is equal to what? Y is still 4. So now what you have, you will have something like this to say, when x is -2, y is 4, and when x is 2, y is 4. So look at this. There is a single value here. 4 gives 2 and 4 gives that. So you can see that this is more of a relationship. Sometimes what is most common is when I wanted to bring a scenario whereby you have got two values of x here. For example, x is 2. You find that you have two values of y. Now let's say y is -4 and 4, where for every, this is the domain, you have got two values of the range. So this is not a function. It is simple a relationship but not a function. Alright. 2.3.4 is the graph that asymmetrical or symmetrical about the x-axis. So I come here to this graph and I have line of symmetry about the x-axis here. Let me make it bigger. Say this is my line of symmetry. They said about the x-axis. If I reflect this graph, you will see that this graph will come different. To say, I will have, if you reflect it along the x-axis, this part, which is a -3, will become 1, 2, which is +3, will become here -3, like this. It will become here as, and this part here, this part, what is -5, will become a +5. Here it will become a +5. It will become there. So now if I can draw this graph, it will look like this. See that? Now what I've done is I've reflected this graph along the what? Along the x-axis. Now if they're saying, is this graph symmetrical? This graph is not symmetrical, because you can see, if I can reflect, let me just make another example of a symmetrical graph. If they give you something like this, just so that you can understand what I'm trying to drive at. If I give you something like this and I draw a graph that is like this, so what it means is, if I take this graph and reflect it along the y-axis, you will get this graph. You see, so meaning if I remove this graph like this, if I remove this graph and I reflect it along this axis, I'll get a graph similar to this. So this graph, you say it's symmetrical when you reflect it along the y-axis, but when you reflect it along the x-axis, you are going to get a new graph. So that's not a line of symmetry. So even here, you see, when I reflected it along the x-axis, I got a new different graph, which is this graph. So this graph is asymmetrical. Alright, so that is the answer there, to say it is not symmetrical, but it is asymmetrical. So the answer is that. Draw the graph of, now next one, I think it's something different. It says we need to draw the graph of x is equal to -4y squared. Again, they said in a way kind of use a graph paper here. It's also not a complicated graph. If I draw that graph, it will be something like this, to say this is my y, this is my x. So it's what? X is equal to -4y squared. You must get used to these graphs. It's -4y squared. It's a graph, more, it's a sketch, so I'm not going to do much here, but what is important is the shape. You can maybe have one point to say, when x is 0, y is, when y is 1, and then x is when y, look, if I say y is equal to 1, so it will be x is equal to -4. Even when y is equal to -1, x is equal to -4. So if I can say this was -4, in here you'll get a +1 here. So y is 1, and even here it's 1 to 3, 1 to 3. So even here y is -1. So this graph is supposed to pass through these 2 points. It must supposed to pass through these 2 points, that point and that point. So if I'm drawing this graph, something like this, that is the graph, because this kind of becomes my reference line I'm using, like that. So you see that. So this is the graph of x is equal to -y squared. 4y squared. Now look at the questions here they brought in here also. Is the graph of this asymmetrical? Is the graph of -4y asymmetrical about the y, or the, I think they wanted to say symmetrical. I think I copied this wrong. Is the graph of that symmetrical? It's supposed to say, is the graph of x is equal to -4y squared symmetrical about the x-axis or y-axis? Come and see that. You can see that if I have my line of here, if I have a line like this, I can reflect this graph, can actually become that graph if I reflect it. So it is about the x-axis, but if I reflect it along the y-axis here, if I reflect it along this line, I'll get a different graph. The graph will be something like this. If I reflect it, it will be something like this. So you see that it's a new graph now. This is along the y-axis, but if I reflect, this will become that and that will become that. It means it's symmetrical about the x-axis. So the answer there is, it is symmetrical about the x-axis. Now draw the graph of another one. Draw the graph of this, of x is equal to 9 minus y squared. Again, if you draw the graph, remember such graphs is more like you are dealing with a circle, because if you square both sides here, you will have x squared is equal to 9 minus y squared. If you take y to the other side, you have got x squared plus y squared is equal to r squared, which is 3 squared. And this is a circle. So if you are drawing that part of the graph, though, this part of the graph, it means you need to identify it's a circle, but x there is positive. So if you can draw that graph of x is equal to square root of 9 minus y squared, you must know it's x is equal to square root of 3 squared minus y squared. 3 there is important because, as you saw, this is the radius. Alright, so your graph then becomes something like this here, to say you'll have a graph like this. So this is your y, this is your x, and what you need is, okay, let me try to have my drawing instruments here to say, if I'm to try to draw this graph as small as I can, you know, in here, I'll have a graph like that. And in this graph that I'm having here, we are saying, as I said, this is the graph I'm having. It's a circle, but now remember, I need to make x positive. It means this graph only has the values of x which are positive. Any value of x which is negative is not part of the graph. Why? Because it says the positive value. If they say it plus or minus, it was going to be that graph. But now it only focuses on the positive value, meaning I must come here and erase this side of the graph. See that? And you erase also this side. It does not exist. So this side of the graph is not part of the graph. So when you do it now, remember that is your radius, the length there. So you have got a 3 there, and you've got minus 3 there, and you have got 3 there. So that is this graph that we're talking about. And then the question was, what is the range of the graph? Meaning, what are the y values? What are the y values of the graph? You can see the y values of the graph. Where do they start? They start from 3 to -3. So you can say -3 is less than or equal to y. Y is less than or equal to 3. Or you can say in here 3, put this in, and then do that. I mean -3 to 3. Then you put that. It's up to you how you want to represent it. You can say y is an element. Y is an element of -3 to 3, or -3 is less than or equal to y. Y is less than or equal to 3. So that's how you also do that. So guys, this is 20 marks. Not really complicated to say, but kind of gives you an idea how you could have answered question number 2. Now remember guys, if you want to be notified every time I'm bringing in some new videos and everything, subscribe to this channel so that you can be notified. I will encourage you to subscribe right now. We have come to the end of our lesson. Thank you.